Hello everyone, and welcome to my presentation about my final year project. During the span of this project, I've designed and developed a mobile application called Beats for the automatic assessment of percussion rhythm imitation. The application allows for users to listen and imitate a percussion beat. It then compares the two beats against one another using linear programming and identifies and displays to users what they did wrong. The target users for this application are beginners who wish to learn more about percussion instruments and basic music theory. First, let me walk you through the application and explain how to use it. Unless previously logged in, the application will open to the start page, after which the user can choose to log in or sign up for a new account. After successful authentication, the application will be redirected to the home page. The home page not only displays the user's username, but also allows for easy and direct access to the pre-recorded recordings page and the live recordings page. The bottom half of the page holds the previous imitation scores of the user. If the user has not imitated any recordings yet, the following message will be displayed. To imitate a pre-recorded recording, the user can either click on the pre-recorded recordings button on the home page or open the menu using the menu icon at the top right-hand corner and click the same button in the menu. This page holds several percussion beats that are stored in the application's database and are known as pre-recorded recordings. User can either scroll up and down or search for recordings by entering any keyword into the search bar. Upon clicking a recording, a set of instructions will pop up for the user to read through and understand what to do next. The user can close the pop-up page by clicking on the Close button. On the imitation page, the user will see the name and the duration of the beat. The user can listen to the recording by pressing play sound. The user can listen to the recording as many times as he or she wishes to. Once ready to imitate, the user can click on the Recreate button. As soon as the timer counts down from 3 to 0, the user can start tapping the left and right circular buttons that imitate a pair of drums. The duration timer also increments simultaneously per second as the user recreates the beat. Once done, the user can press the Stop button and be redirected to the imitation score page. Here, the overall imitation score is calculated according to the comparison algorithm and is presented as a percentage. To learn the exact errors that were made, the user can press play sound to simultaneously hear and visually learn what the error was. The user has to retry the recording at least twice to ensure complete understanding of the beat. After 3 imitations, the user can return to the pre-recorded page to select another percussion beat to practice with. Should the user return to the home page, the user's latest imitation and the highest score achieved for it will be presented in the previous imitation scores table, along with a shortcut button to allow the user to retry the song on the spot. Let us now see how the imitation score is calculated. To compare the two recordings, we first need to understand what are the key features that make up a percussion beat. Any sound is made of 3 main features: amplitude, which is how loud the sound is; frequency, which is the tempo or the beats per minute of the sound; and the timbre, which is the complexity or the rhythm of the beat. Since the application does not take in any auditory input, but rather the tapping of the 2 circular buttons, we will not consider amplitude and only focus on the tempo and the rhythm of the percussion beat for the algorithm. The comparison algorithm comprises of linear programming, which follows the following format. Here, A is the final imitation score, X is the percentage of tempo similarity, B is the weightage assigned to tempo similarity, Y is the percentage of beat similarity, and C is the weightage assigned to beat similarity. To obtain the percentage similarity in tempo, first, the total number of beats per minute for each recording is calculated. Next, using the simple formula of difference over original, the percentage of tempo similarity between the original and the imitated beat is calculated. To obtain the percentage of beat similarity, the algorithm traverses through the original beats and at each tap obtains the value of the imitated beat at that particular index. Since human reaction time is around 150 milliseconds, the previous 2 and the next 2 indexes are also retrieved if the value of the imitated beat index does not match that of the original beat. Finally, these values are inputted into the final percentage function. The weightage assigned to B and C is 0.2 and 0.8 respectively. This is because the skill of controlling speed, while necessary, is a more advanced skill that users may take some time to master, and hence a lower weightage is assigned to tempo. A user should receive a high imitation score if he or she manages to play the whole beat accurately, although slowly, but receive a low imitation score if the tempo is extremely similar, but there are several missing beats and there is an incorrect rhythm. Once the comparison algorithm generates the final imitation score, the display of errors component is implemented. This component is responsible for listing out the errors to explain to users where they went wrong. The purpose of this is for them to understand what they should have been playing and to understand the fundamental music theory behind why they went wrong. For this display, the name of the percussion beat and the imitation score in a circular progress bar is displayed at the top. A waveform of the original percussion beat is retrieved to showcase to users where the high points of the beat are. High points are generally the points where the user is supposed to tap the left or right circular button. Below the waveform, a music bar is presented for users to see the progress of the percussion beat as it is played. They can press the play sound button or the pause sound button at any given moment. As the music plays and the music bar progresses, the errors at that exact time mark are displayed simultaneously to allow users to visually and orally learn their mistakes, since playing a rhythm is also about listening to the beat carefully. At the bottom of the page lies the retry and return to recordings button. The list of errors that is printed out one by one is possible because of the get left error lines and the get right error lines functions that identifies the errors made by the users in the left-hand side array and the right-hand side array respectively. It then proceeds to print out the errors systematically as the music progresses. With this, I've come to the end of my presentation. Thank you very much.